Hello again, and welcome to Programming Problems Episode 9. Soon we shall continue with our series on Advent of Code, but this week we shall take a look at one more problem from Kattis. This week's problem is called Backspace. Let's take a look. In a programming contest, one contestant notices that his backspace does not delete the last character that was typed. Instead, it outputs an angled bracket which points to the left, perhaps more commonly known as the less than sign. Not wanting to solve the problem with the keyboard, we are asked to write a program which fixes the resulting wrong text. So given a string, what was the intended input of the contestant? Now for the constraints, we are only given a string and it can be at most 1 million characters long. Let's have a look at two examples that we're given. Suppose the text we get is the following. We can see that there are two backspaces inserted into the string, one after A and one after C. Naturally, the A and C should be deleted and the intended string is simply B. Now, for example 2, we get a string which has two backspaces after each other. Imagine that we typed this. Then, of course, the first backspace removes the last letter S. The second backspace removes the one before that. We are then left with the output string for a ton, which is the answer. At this point, you perhaps already can solve this problem yourself. Please feel free to go to the problem on Kattis and work on it before continuing this video. Maybe this is not needed for most of you, but as a final insight, do consider the length of the input string. 1 million characters suggests that we cannot do any n-squared solutions. Is it possible to do this linearly? I'll wait a moment, and then let's continue to two solutions which I have prepared for you. Let's continue. The first solution which I've chosen is to simply move forward through the string. As we go through the string, then we can build the answer like a stack. If you're not yet familiar with the stack data structure, then please consider subscribing. We shall cover this in a future video. Using a stack, we can easily pop the last letter from the stack every time that we encounter the backspace character. Finally, once we processed every character in the input, we just have to iterate over the stack to build it into a string. Note that, of course, the alternative is to perhaps not use a literal stack, but to immediately build the resulting string. We can still treat it as a stack by removing the last character when needed. This solution would work as follows. First, we insert E, then X, and X again. At this point, we see a backspace character, so we remove the last X from our result or stack. We repeat this process for all characters in the input, and we're left with our answer. An alternative solution is to process the string backwards. If we process it backwards, then a backspace character indicates that we skip the next non-backspace character. Thus, we loop over the input string in reverse and keep a counter for backspaces. If a character is a backspace, we increment the counter. If it is not a backspace, then we check the counter. Is the counter larger than 0? Then we skip the character and we decrement the counter. Is the counter 0? Then we just add the character to the output string. Finally, of course, we need to print the resulting string, which may be in reverse depending on how you constructed it. This particular solution would work as follows. We start at the end and we create a counter which starts at 0. Then we consider the letter E. The counter is 0, so we add it to the answer. Same for the following letters. Then we encounter two backspaces, so we increment the counter twice. Then we see an A, and here the counter is 2. So we skip it and decrement the counter by 1. We can repeat this until we have the complete answer. Note how we now never have to remove characters from our answer. We simply don't add what we don't need to add. So in a way, this is slightly more efficient. However, both solutions are just as valid. And that's it for this week. Thank you for joining, and do be on the lookout for next week's episode where we will continue our journey into Advent of Code 2015.